Good morning, all. I welcome you for the lecture series in the course Manufacturing and Measurement Techniques. We are in the Unit 4, Measurement of Linear Angular Dimensions, and our today's topic is Linear Measuring Instruments. So you can see a giraffe here in the right side. You all remember seeing in National Geographic channels. So what do you remember when you remember about giraffes? So nothing but your height, right? So this height is nothing but linear, and we are going to see how we are going to measure all these things. So coming to the empathy part, why we need linear measuring instruments? As a baby, we grow from small child. When we born, we are putting into a scale, seeing the weight as well as the height. And after that, the essence of growth is measurements, and we are looking for linear growth in the terms of height. So where we use a linear scale for this height measurements. Likewise, this analogy holds good with all the manufacturing components we manufacture for getting a car or any other component. We need linear measuring instruments. I hope you understood what is linear measuring instruments and why we require this. Yes, today's topic for discussion is why linear measurements are important. And the second point is classification of instruments. And the third point is various measuring instruments. And the fourth one is application and conclusions. So coming to the significance of linear measurements, not only we use this linear instruments in manufacturing, we have several sectors which is utilizing this linear measuring instruments. Let us take an example of in construction. It ensures structural integrity and alignment. And in manufacturing, we can see it facilitates precise production process starting from design to packing. And in navigation, it aids accurate positioning and route planning. Without linear measurements, we cannot go or sail across the sea. And in science, it supports data accuracy in experiments, even though it helps in personal activities which enhances daily task efficiency. So coming to the measuring instruments classification, we classify this linear measuring instruments in three categories. One is direct measuring instruments. You all see a small Vernier caliper diagram here. Right from the 6th standard, we are being introduced with this. It has a lower jaw for internal measurements and upper jaw for external measurements. When you want to measure any kind of dimension, you can directly read the reading from this Vernier scale and find the dimensions. That's why it falls under this category. And we have micrometers, height gauge, and depth gauge. So the second classification is indirect or comparative measuring instruments. It is used to compare dimensions with standards like dial indicator, slip gauges, and optical comparator. As the name indicates, it gives only the variation of the dimensions, not the direct reading. So coming to the third classification, we have precision reference instruments. So whenever you want to compare any standards, you have to go with the precision instruments. And those precision instruments in metrology, we have master gauges, we call it as slip gauges or Johansson's blocks. And sign bar is used with slip gauges for precision measurements, and N standards are used for the same. So let us have a small recap of all the things what we have studied in the previous slide. Here, linear measuring instruments are categorized into Vernier instruments, micrometers, gauges, comparators, specialized linear instruments. So we have a small challenge here. A shaft is measured using a vernier caliper which is having a reading of 24.98 and outside reading of 25.01. The actual dimension of the design is given and you need to understand and solve these three questions which is here. Yes, we have come to the assessment part. The least count of standard vernier caliper is given as 0.1 and 4 values. Yes, the answer is B, that is 0.02 mm. The second question, which of the following instrument provides the highest precision in linear measurement? Yes, that's micrometer. It's 0.01 mm. And I hope you all understood what is linear measurements and what is least count. And we have seen a mind map here to understand better. Here are the references. You can go through and explore more. Thank you.